Okay, great. So I think that's now we can proceed. 1 second. Okay, so yeah, okay. So today my topic is application of variety research achievements. And what I want to do today is that I want to start with a brief introduction and overview of our lab, what we are doing and what's actually we are working on. And also I want to talk actually about the mm, the path which we passed, so what we have learned, and so actually how things were uh, went through, and so how we came to the game development from being kind of research laboratory and coming to all the things. So let me start from talking about who we are, right? As it was already shared in the beginning of the introduction, that I'm a head of laboratory which is called COSM, and this big international research lab, and it's a research and development laboratory because we are doing a lot of different things, and full it states for cloud-oriented solutions and modeling, but we like the short version. So currently, as of now, as of today, we have pretty big team. So we have 36 students working in our university. So in general, with the students who are working with us from other universities, we have up to 42 people. So including people from Brazil, India, Mexico, and a couple other countries. Also, right now, all this large team, so with all these people which we have on board, actually working with 13 projects. So these projects are related to development of some systems or performing researches in some areas, and most of the projects are a teamwork. So you can see that we have much fewer projects than team members. So usually we have 1, 2 people in a team, but we have teams up to 5 people. So one of such project is actually the one which we are going to talk today during this keynote. The next is that we have our own cloud environments, so which are located in 2 different data centers. So it means that all the projects which we are doing, so we are not spending money on different cloud providers or whatever. So we're not working with Amazon or anything else. So we are developing everything on our own hardware. And it's important that we are doing this in that way because we're teaching students to work with everything like this. So it's not like we are only training them to be users of the cloud, so they can use a cloud platform and develop and deliver their applications there. So, but here we are also talking about the ability of our students to actually build a cloud environment and develop our solutions on all levels, which are actually right now applicable. And with this in mind, we can move forward and see what we are working with. So currently, we have 2 main areas where we're applying all our efforts. So the first one is the development of a cloud solutions. So largely, this is actually maybe not most, but about 60–70% of what we are doing is actually development of the cloud solutions. The second part of our activities is simulation of complex dynamic systems. So we are working a lot of this, and our main instrument is the system dynamics. Our team is an active member of international system dynamics community, so we are frequently participating in their international conferences. So our team is members of 2 committees in this community. So we are member of tools committee, so which is actually about all the tools which are developed around system dynamics. So everything what is open source, what is available, and so this also we are there because we are making tools for system dynamics too. And another is the committee for the XML standard. So an XML is a language which is used to actually describe system dynamics models. And here we are also participating, working on this standard, and I think we have our suggestions which were applied and actually implemented the standard. So while working with the development of the cloud solutions, we gathered a lot of experience on how to design, build, test, and deliver useful solutions in the cloud. So how to do this from scratch, like from result from requirements gathering, from figuring out the use cases and so on, to building the design, building the solution, testing and delivering, and now even maintaining it. So because the metric for 13 projects is running projects, but we already have a completed projects which are actually running in production, and they have real users. And so in most cases, we have no idea who these users are. So this is just people who are using our solutions which we are making. And since we are working with the simulation of complex dynamic systems, we learned a lot about how to build a complex dynamic models for existing or imaginary systems which are evolving over time, which are changing over time, and which are actually implementing a pretty complicated dynamics. So with these two major streams we are with, so we have kind of our capability matrix, which we have. So for development, we have 13 running projects, and 5 of them, not of them, but 5 are completed, right? And they are working and running in our cloud. And you can actually go register and use our tools, which we are developing. And for these 5 projects, we have about up to, I think, about 1,000 users we have. And I think it's actually a good metric, taking into account that majority of things which we are doing are oriented to researchers, scientists, and so on. So it's like data analysis, working with the time series, and so on and so on. Also, we have very interesting experience with having 6 complete research projects. So the research project is a completely different story. It's not like an instrument or a tool which we developed. This is actually real research. So one of them we performed with our colleagues from India, for example, from Tapar University. This was a very interesting project about virtual machine placement. So what are the best algorithms? So we were validating existing algorithms, proposing new algorithms, and so on. So, and we still have some projects which are kind of following this topic, and we're still actually working with these topics of virtual machine placement. Another thing is that we have a bunch of projects where we were doing a simulation for real customers. So, for example, we worked with one logistics company in Europe for whom we were building the model to perform the predictive maintenance for their fleet, for their vehicles, and so on. So we gathered a lot of experience about logistics, about maintenance schedules, about everything else. So we also have experience when we have a joint project with one of the European universities when we were simulating traffic congestions and so on. So we are working also in area of routing and so on. So I'll talk about this project a bit later. So, but in general, so we have 2 large streams. It's one is a purely R&D, so where we actually do the software and we are trying to do it in a good way with all the best practices and so on. And we have a stream with a purely research projects where we actually trying to solve real world problems with our tools, with other tools and so on, but mostly with the system dynamics. So because system dynamics, our main instrument, which we are trying to apply where it is actually reasonable. So what else? What have we learned from this, right? So we went a long path. So we tried many different things, and we actually were learning all this time. So our lab is working for about almost 10 years already, and we are gathering pretty much experience. And where is this experience? So mostly I want to talk right now about our experience in system dynamics. So with the system dynamics, we were doing predictive maintenance. So this is what I already talked about. So this was for a real commercial company which was doing logistics and actually delivery of the things. So, and it was required to build the model to reduce their costs on maintenance. And so I would say that we get pretty good results because we were able for this company to reduce their maintenance budget by 30%. So this is pretty much when you have more than 200 trucks. So reducing your budget on 30%, it was really a good achievement both for us and for them. So we learned a lot. So they saved a lot. So it was actually a good deal which we made together. Then we have a couple interesting projects in area of resource management. So one of this project was dedicated to water resources. So it was about distributing the water in some areas where the water is not very well accessible. And it was needed to figure out what policies can be applied to encourage farmers to grow more different crops, and how to help them to reach out the water. So maybe if they have issues with water, how can we stimulate them to actually advance in development of water infrastructure for them and so on. So a lot of things were there in this research. And actually, besides new edges of application for system dynamics, we also learned a lot from this actually farming business, and how this is working, how to simulate it. So what kind of variables you have there, how these variables connected to each other, what kind of data you can receive, and what kinds of measurements you can. So with it, you can play with so different historical data and different policies which you can apply to actually stimulate or prevent something, and so on and so on. So this was very interesting journey. And another project which was also related to the resource management, let's say, was about the energy. So it was for some region. So we're trying to simulate resources. We're trying to simulate different models of what is the best way to actually build energy system for some region. So it was for one of the US regions, so one of the parts of the states. And there we're taking into account a lot of things like solar energy, windmills. We're talking about the different power plants and so on. So, and trying to figure out what kind of a balance we can get. So what kind of an equilibrium we can reach, which will be the most greenish, which will be the most safe, secure, and in the same time, so if anything will go wrong with the weather, on which all this greenish energy sources are very dependent. So what will be the options to actually keep everything plugged in and everything working in the state? So it was very interesting and big work. And in this both cases, we actually advanced a lot, not only in the areas, right? Because we learned a lot. We actually dive deep into this energy industry. So how the energy is distributed, how it is produced. So a lot of knowledge here. And another was thing that we are very advanced in our usage of system dynamics, because with every new project we were doing, we were finding new and new ways. How can we build models? How can we validate these models? And how can we actually work with these models to figure out something? So find a solution for the problem. In many cases, we need not only to find the solutions for the problems, we need to find first the problems, right? Because if you see the system and you can say, oh, something wrong with it, right? Before you can fix it, you need to find a concrete root cause and figure out so what is actually wrong. And actually finding the problem is even more complicated than finding a solution. So besides the resource management, we also have experience with real traffic optimization problems. So there we were trying to figure out so what's going on also in some district where they have a problem with the traffic congestions. And so we were building different simulations to see why actually they do have this. So how can they reduce the traffic, or figure out so where it is better to improve the road network to actually give more space for the cars actually to pass this traffic jams, and so on and so on. So actually there we dived very deeply in how actually the transportation network in the city working, including so many different aspects, including the comfort of public transportation, price of fares on the public transportation, right? So comfort of driving, and so on and so on. So a lot of aspects actually we take into account, and we actually built a really complex model for this. So if I'm not mistaken, we end up with about maybe almost 200 variables which were put in place, and much more and many more dependencies between them, so which we also analyzed and worked with them. So it was really very big work, and I would say that this is one of the was the largest models which we actually built by our own for actual problem solving. So one more area which we gathered experience was the population and urban dynamics. So actually the project was about, it was one of the cities in Europe, and the problem was actually with the population. So it was in Spain, and in Spain they have some problems with that. Some cities are actually became abandoned, so people are just moving out from them, from the cities, and they are becoming actually uh, they're becoming pretty empty. So, and mayors of such cities are very interested in actually figuring out why this happening, and not only why this happening, what can be done on a city level just to move people back. So to build some circumstances under which people will start to move back into the city. So what's actually the critical elements which will help bring people back. And so there we also learned a lot about how to simulate the population, because there are a lot of aspects which are uh, affects the population. So from very simple ones like birth and death, right? So we have migration, positive and negative. So people coming to the city, people leaving the city. So, and we were trying to figure out all the conditions and all the factors which are affecting this, and trying to build a model which will realistically reflect what's happening in this particular region. So, and this was also very interesting work. So with all these things in place, let's see what we learned. So from predictive maintenance, we learned a lot how things behave and how they degrade. So if something is actually working, it's some machinery or whatever, right? So it's actually running out of resource one day, and we need to be able to figure out how this is happening and what are the practices are for simulating this. And we actually did a good job here, and we learned pretty much from this exercise. From the resource management, we learned a lot how resources are transitioned and transformed. So because there's actually only two things from modeling perspective which are make sense. So how you're moving things and how they're transformed from one kind to another. For example, if you are actually transforming like coal into energy or wood into furniture. So how these things are working, so what factors can be, and so on and so on. So from the traffic optimization project, we learn how routing affects everything. Because actually, if you have the pretty nice model and you have pretty nice environment which is working well, if you will start seeing the problems in the logistics instead of it, logistic can ruin everything. And this is very important on how this can be taken into account and how can we actually work with it to balance our system and make it actually even work better, or if we want to make it worse, so what we can do with it. And from the urban dynamics, we learn how cities are growing, so which factors actually make sense, and so what can be applied and where, and actually how can we affect this, so can we enforce cities to grow or to shrink, so what we need to do this in a most efficient way. So plus, on all these experiments, so important part was actually the policy management. So it's actually in the system dynamics, it's a very important aspect. So when we are trying to figure out, so, okay, let's say we have a model, and so now we need to figure out how can we actually influence on it. So what we can do to get this model to a certain state. So this actually kind of covered by policy management. So what kind of policies we will apply in this model, so to change its behavior. Because another important thing is that frequently we, even if we want to make a changes in the model behavior, we never, no, okay, I will say never, but frequently we are not interested in immediate changes, because if we are working with the real world scenarios, so actually almost any immediate change will be breaking. So it means that you need not only to think about to which parameters and to which state you want your system to come, but you also need to build a proper trajectory, how the system need to come to the state. So, and this is one of the most complicated parts. It's not actually, it's not that hard to find how to push the system into a certain state, but it's really hard when you need to think about how can you push your system to a certain state according to some trajectory which you need to do. So this became much more complicated problem. And so actually a lot of knowledge, which we gathered. So a lot of connections we made. So we met a lot of people who are working in this or that particular area. And so actually this is kind of a huge virtual expert group, with which we actually periodically working, and we are getting back to these people and sending a lot of postcards on different big holidays like New Year and so on, to remind about ourselves. So can we somehow sum up all this experience? So can we put together all this knowledge to something big and interesting, right? So because if you collected a lot of something, you need to invest it. So is it money or is it knowledge? If you are not investing it, you are losing it, because if you're not using this knowledge, you're starting to forget things. Even if you have papers, you have wiki pages in your system, anyway, you're losing your knowledge if you're not actually using it. So, and what we decided to build a game. So maybe it's, yeah, not very obvious move. So, but this is actually what comes to our mind. And with all the things which we learned about logistics, about manufacturing, the production, and so on, we decided to build a city model, a model of a real city with a lot of aspects which we are taking into account. So I will try to mention here, let's say, just the most major ones, like, for example, energy. We learned a lot about energy, so we can do the pretty good simulation. And actually, this what makes me interested in connecting and talking to the second keynote speaker from the yesterday uh, conference day, because there was a lot of super interesting information about the visualization, and it was actually related to different energy aspects. So when we're talking about the production and consumption of energy, so all these charts which were shown, all these visualizations, they are simply amazing. And actually, I will be interested to see how they can be incorporated potentially, if it's possible, into our game, because we can actually bring incredibly new gaming experience for the city building games with this kind of visualization, because I haven't ever seen anything like this. So this was really cool and very interesting to us. So the next is the manufacturing. So when we are actually thinking about almost any city building game, we will actually see that you're always building some mines, you're building some factories, you're building something else. And actually, you're always, actually, all city building games are about the materials and resources, and about their transformation, transition, acquisition, and disposal. So everything what looks like this. So we tried it, we learned about it, so we can use it. So, and we can extrapolate our experience with the water resources and energy resources to other areas. So, and potentially we can actually even learn more about, for example, mining industry and so on. So how can we simulate this and how this is working? So logistics, right? So I was already talking about this. So we have very interesting logistics project. And actually, when we are thinking about city model and city building game, so logistics will be a big part of what we are doing, because you are not only putting the buildings on the map, you're connecting them with the roads. And the way how you do this actually should very deeply be reflected on the whole system behavior, on the whole behavior of your city. So that is why logistics and how you're building your roads, how you're connecting everything around, should play a crucial role in actually, will your city grow or not? And how all your manufacturing and production lines will be working. And one more thing, which is obviously we can't miss, our experience and our knowledge about the simulation of the population, right? Because people needs to come and go, people needs to actually appear in the city and disappear due to different reasons. So we can actually gather all the things and put them together into one model. So as an outcome of this, actually putting all these aspects, I'm just listing 4 here. Actually, right now we have 12. So I'm just don't want to overload the slide, because so I just putting the measures which are connected to our directly connected to our experience. So putting all the things together into one model was very challenging problem, because so by nature, the system dynamics models, the more complex they became, so harder it to maintain. And here we come to the kind of a way to build what we call a multi-layer system dynamics model. So that's actually what we get at the end. And here in this model, we are putting all these actually elements and all these aspects and so on. So I added some more icons here, which are actually showing the fact that when we're talking about every aspect which we are listed here, like energy, manufacturing, logistics, and so on, and population, so we are not only relying on our own experience. So we periodically getting back to the people with whom we were working, right? If we have some questions or we see that something is unclear, for what we want to put in a game model, because we want to make our game model super realistic, right? So we want to make it actually based on what we have in reality. And that is why we're also referencing a lot of research papers. So we have a tracking for every area in which we are working of the new papers which are talking about the simulation in these areas. So simulation in energy and manufacturing and so on. So we're tracking all the things to put the most recent achievements, to put the most recent published information into the way how we are building the model for our super cool, super realistic city. So this is actually why we have all these icons with the scientists and research papers here. So they depicting that we are trying to always keep on the edge, on the top edge of what's happening in every industry, what we are trying to simulate right now. This is why actually this bring another challenge for us, because behind this project which we are doing, we have a huge amount of knowledge. And I think that maybe on some other conference, if they will be talking about knowledge management and data management, I think that we will also have interesting things to tell how we are actually managing this huge amount of information and how we're keeping it up to date. So, but it's actually just a completely separate topic we can cover on a different session. So one more thing about the multi-layer model which we created. So the thing is that usually when we are thinking about that, we want to put some element in our game, right? For example, we want to build a factory. So this factory will be actually a composite object, right? But when we're talking about our game, we have the thing that it's not a composite. So it's actually split into many pieces. So for example, when you're putting a factory inside a game, so it's not our game asset, so our game looks differently. So more realistic actually. So when we are doing this, we are actually putting part of this model into the part of this building in the energy plane. So part of it we are putting in the manufacturing. So part of it we are putting in the logistics because it affects logistics level of our model. So part of it we are putting into population because, for example, in some region, if you're putting a big factory, it can actually affect, let's say, how to call it better, so attractiveness of this district, right? So because if you have a big factory, maybe people will not want that much live near it. So that is why actually every time you're adding something into the game, so it's actually split with a lot of small pieces all around different layers of the model, what actually makes it simulation more realistic, because this is actually pretty much how it's happening in the world, because all these actually planes are working in parallel, but they are a little bit separated from each other. And it was challenge for us to make them all these layers to also play together, right? So they're not completely dedicated. So there are way of between these layers to communicate, and everything done on a level of the model itself. So from the game to the model, right? So the crucial element here, which actually do huge work for us. So we put a lot of efforts in building it. So we have a game. So and we have a map with all the buildings put on it. So all the roads, beautiful parks which we are putting, and so on. And at the end of the game, what we are interested in, it's not this part of the game. We're interested in the model because we need to bring dynamics into everything which is happening in the city. So, and for that purpose, we created a thing which is called model generator. So this is something what actually eats configuration of a concrete world, and it generates a huge system dynamics model. So the largest model which we're able to build, so actually on a test stand, we created a large city with a lot of buildings, factories, everything else, and we turned it into the model, and this model had about 12,000 variables. So the good thing is that our environment in which we're executing it was able to execute this model easily. So because it's not that big actually for our execution gears, but so actually this model, if you'll try to build it manually, will be simply unmaintainable. But it actually inherits and implements all the rules, practices, and everything from the system dynamics. So this is truly naturally system dynamic model, but it behaves like system dynamic model. You can deal with it. You can research this model and so on. But you will, I think, never you will be able to build this model manually if you will try to build it as a model. So, and to build this model, you need to know several things. Resource definitions, which you have in this world, and building definitions. So to know how this building actually, what they're consuming, what they're producing, what kind of resources you have, and so on. To this part, like resources and building definitions, I'll come a little bit later, so I think I still have some time. So I just have 3 more slides, so I'll try to be on time. So the overall architecture of the whole application, it's actually a pretty big system, but simply it looks following. You have a game clients. It can be either mobile, web browser, or can you install our game application directly on your computer, so you can deal with it. We have a game servers which are doing a lot of actually housekeeping for us, so keeping information about your world configuration, so how you put everything on the map, your profile, so just general thing. It's pretty, I wouldn't say that it's in any way is revolutionary, but except the part which is called model generator. So the model generator is actually the main part here, which is turning the worlds which are created by players into the system dynamics models. And at the bottom of this, we have our another project, which is called SD Cloud. And SD Cloud is something what we launched in 2015, and it's really mature, big project, which is about it's a cloud platform for executing system dynamics models. And right now, our capacity is to execute 8,000 models in a parallel. So it means that 8,000 worlds created by users can be handled by our existing infrastructure, but we can scale, so we can go beyond. So actually, every time when user is actually putting a building on a map or changing some characteristics or changing policies in a game, so we are saving his world, then we're translating his world in the system dynamics model and push it down for execution. And these models, which are related to the worlds, actually executed forever. We have a special kind of model execution process which just executes your model at a low pace, but almost actually in real time. So but there is no end time, so it's just executing slowly on the server, and this model constantly generating your simulated results. So you can always see all the information about how many stuff you have in stock, so what's the energy level in the city, so what's about water consumption, so how many people are moving in and moving out. So the all dynamics for the whole world is coming from the simulation result. Actually, it looks like a huge data table with 12,000 columns on this giant model, so for the whole city. So, and data generated, if I'm not mistaken, right now, 2 times per second. So 2 times per second, you're getting new metrics for your city. So you have everything up to date, and you can actually see how your city is evolving and so on. So, and actually kind of major level, like the top level is a gaming experience, and the bottom level is our model execution gears, which we have there. So when we come to this and we develop all the things, so we thought that creating a game, it's a great thing, but it's not enough for us. So sometimes we have actually super ambitious projects and ideas, and we decided to go beyond. So we decided that why are we creating one game? Actually, everything what is shown here, it looks like a pure platform. So what we can do is actually we can go to a platform from a game. And here we introduced a notion of a universe. So actually, yeah, I really like the moments when I'm speaking about the universe. So the universe actually it's everything what is related to the concrete game. So for example, in the universe, you can put all resource definitions, you can put building definitions, game assets, UI elements, and so on. So this what is called universe. And our system takes everything like this, and with it, inside the universe, you can create the user world. User worlds actually are a concrete cities which are built by users. So currently, we are with some completely actually not IT related partners. We are working on several universes because we have our own. So the World Dynamics is a kind of a modern city with all the super realistic things which we are doing. So this is our universe. So we are investing our time and efforts in building it. So, and this is actually what we are actively doing. Along with it, we have some sci-fi world from some fans, so fanatics, fans, yeah, fans who want to do this. So they created completely their own resources. They completing their own buildings, game assets. So they draw everything by themselves. They're just launching it in our platform. And the cool thing about it is that we are trying and we are reaching out some communities, especially, for example, interested in the history. Let's say there are some just just an example, random example, first thing which has come to my mind. We can, for example, work with some society who are interested in, let's say, Russian history, like around 1930s. So how it was there, so how it was on earlier time, like 1930s and so on. And so they can uh, build their own universe on top of it. So with their own buildings, so all productions, manufacturing, so available at that point, different energy sources and everything. So just completely this historical period, or even maybe specific location. Or we can, for example, reach out some other society which is interested in, for example, let's say some region, and they want to, for example, model the village, let's say Southern Indian village, so how it is actually working to actually preserve this as a heritage, right? So to teach people how this region is working and so on. So what we want to end up is to have actually the gallery of these universes in our system. So you will be able to just go there, choose the universe in which you want to build your city. And for example, if you want to learn the history of some district or some historical period or some sci-fi movie, like let's say Star Wars, like I can build a universe around the Star Wars and it will be actually the city in this setting. So with their resources, with their dynamics, with their productions and so on. So completely futuristic. So, and you can just you do this for fun, or you can do this actually for learning and teaching. So teaching historical periods, teaching specific regions, and so on and so on. So actually a lot of stuff can be done here and a lot of can be built on top of this platform for different groups of users. And actually, I want to end up here with a slide which I just titled "What is actually the world dynamics?" because the world dynamics is how we call this project. So the whole this big thing which I was talking about called world dynamics, and for sure this is a game, right? So this is a game which you can register, you can start playing. So you can't register yet because we haven't gone into production, even into beta. So, but we're still working on it. So it's based on real scientific achievements, yes. So with very realistic dynamics of main aspects of life. So that's what we are trying to do for our concrete universe. So we are providing an ability to build own unique universes. Yes, so if you're interested to actually cover some time frame or some location, so you can just build your own universe and allow people to just see how it works and build their city inside this particular time frame or region. And that's why it's helping to study and teach dynamics of various historical periods and places. And also this is the place to innovate and collaborate with the specialists from various areas. Yeah, like people who are interested in history, people who are interested in different kinds of productions, and for example, different industries who actually want to reflect how these industries are working. So everything can be brought inside, because all these details are actually covered by abstraction level of a universe which we are trying to expose. But also, this is a scientific tool. And as a scientific tool, it also works in a many different, sorry, uh, it crashed, but okay, so I see that sharing is still working. Okay, so based on, yeah, interesting, where it gone? 1 second. Yeah, I think still sharing. So it's based on a system dynamic simulation approach, completely purely system dynamics calling all the rules which needs to be used. So with access to generated model and full simulation data, so you can actually go to SD Cloud and get access to the model of your concrete world. You can see what's generated, so you can see the charts, you can see all debug information of this model. So if you are interested actually in researching something, right, you can use it, and you can actually go and build cities with different configurations, then check models which are generated for them, build some execution experiments just to see how these cities can behave in different conditions and so on. And yeah, you're getting all the features of SD Cloud simulation system. And also you can actually pull this model out and use any other tool for system dynamics, free or commercial. So we are not locking the user. So it's their cities, their models. You can take out all your data at any moment. And also allowing to design unique city evolution cases and research this, so different cases, different universes, and so on. So currently our project team is located actually in Russia, USA, and recently we have a new team member from Cambodia. And so actually this is a game designer, so who is actually working on assets and 3D models and so on. So I saw his works and he doing a magnificent job. So, and we're always glad to expand on any level and part of this project which may potentially appear interesting. So we will be very happy to actually cooperate, and we'll be very happy to integrate and work together. So to move this forward, because it's actually very big work and a lot of things needs to be done still. So what we are doing, and we will be happy if anybody wants to join our efforts and join us in this great journey which we started and which we are doing. So actually, I'm thinking a little bit out of time. Sorry for this. If you have any questions or comments, I will be very happy to address them. And if you will have them after the conference, I will be also happy to get in touch and discuss everything. So yeah, that's I think pretty much it. So I think that I can pass the word to organizers. So Professor Bagwari. Sure. Uh, what do you understand as a drawback? Actually, in our environment, in our lab, we are trying not to actually think in the terms like what's wrong or what's right. So we were trying to try everything. So that is why if you will have any suggestions or ideas, actually we can just discuss them one by one. So because we don't have like defaults on so what do, what not to do, what and so on. So we are looking at any possibilities, any collaborations, and we're trying to consider all possible options which we can find. So that's why if there will be queries to join us and do the master's or bachelor projects with this area, so we will be super happy to discuss all suggestions. Thank you for your question. Okay, if there is no other questions or comments, I think I'm done with my keynote. So I can maybe stop share. And I think that conference organizers can always provide all the contacts. So it's very easy to reach me out in WhatsApp. So I think that Professor Bagwari can share them with everybody who will be interested. Thank you so much. Thank you.